Okay, now we're starting to look at this new unit of trigonometry, and I want to spend some time here to talk about the key terms and the key words that will go along in this unit that will help you out later on. So this is nothing really deep. It's just words and terminology so that you're familiar with them and you can use them to do some real trigonometry questions and problems. First off, trigonometry deals with right-angled triangles, and in the next lesson I will show you more of the ins and outs of how this all works, but just for now, trigonometry deals with right-angled triangles, which again are triangles that have a 90-degree in them. And there's three, remember back to Pythagoras, there's three parts to the right-angled triangle. There's the part that the boxy thing always points to, and we had called that the hypotenuse. Or, in Pythagoras, we called that the c side. A squared plus b squared equals c squared. We said that was the c length, that's the c squared. Also called the hypotenuse. Okay. And then in Pythagoras, I always say that this side and that side, your a, your b, you could interchange them. You could make this your a squared, or that your b squared, or this your b squared, that your a squared. Well, they actually have names. And the name depends on the angle that we're interested in. Okay, first off, we already know that this is 90 degrees. But we don't know the length of that, or the degree measurement of that and of that. Maybe you remember from before that all the degrees in a triangle should add to 180. But let's pretend it's this angle here that we're interested in. We don't know that angle there. Now you should know that when you don't know an angle, you don't have to put a question mark. You could put a variable, like x, like y, like the letter A, like the letter B, whatever you want to do. In angles, in trigonometry, for an unknown angle, they tend not to commonly use x's or y's or things like that. They tend to use capital letters like A, like B, or more commonly for angles, for unknown angles, they use what's called this little symbol right here, theta. Theta. Theta just stands for some unknown angle. So let's pretend we don't know what this angle is right here. Angle theta. It's a Greek letter. This side here is opposite that angle. So that's exactly what we call this side here. The opposite side. It's opposite from that angle. Right opposite. Now, there's theta, the angle that we're trying to find. And the angle that's the side that's right next to it, or below it, right next to it, its neighbor, we call that side the adjacent side. When you're adjacent to something, you're right next to it. All right. Okay, so these are the three sides in a right angle triangle when we deal with trigonometry. Opposite, directly opposite the angle. The adjacent is right next to the angle. And the hypotenuse is always the c side, or where the boxy thing always points to, the slanted side. Okay, so let's label these two triangles, hypotenuse, opposite, and adjacent. Now again, it all depends on the angle, and whenever you see something like that, that means that's the angle we're talking about. Or they'll actually put the little theta symbol in there to mean that's the angle we're talking about. We don't know what that angle is. So then to label this with these words, opposite, adjacent, hypotenuse, here's how you do it. The opposite's the easy one. Just take the angle and what's directly opposite from it. That's the opposite side. The hypotenuse is also easy. That's where the boxy thing is always pointing to. So that's your hypotenuse. Hypotenuse. And the side that's right next to the angle, usually kind of like below it, that right there is the adjacent side. Adjacent. Okay, so label hypotenuse, adjacent, and opposite for this triangle here. Here's the angle, Now, again, I should have labeled it theta, meaning some unknown angle. What would this then be? Well, that's right next to the angle, so that's your adjacent. This side is right directly opposite from that angle, so this is what we call your opposite side. And the boxy thing points to the hypotenuse side. So there we were able to label adjacent, hypotenuse, and opposite on these right angled triangles. Okay. Now, what was the point of that? Well, the point of that, and we're not going to really deal with any numbers really today in this lesson, it's just an introduction, is in trigonometry there are these special things, special little, almost like translators, magicians, that allow us to go from side lengths, once we know the lengths of these sides, to missing angles. And sometimes allows us to go from, if we know what the angle is, we can figure out what the lengths of the sides are. So like I just said, in trigonometry there are three functions that translate between angles and side lengths. And this only works for right angled triangles. Well, not really, but for simplicity's sake, say for right angled triangles. So for example, if I already know what, let's say, that side is, and I know what this side is, I can figure out, actually, Pythagoras says we can figure out what this side is too, right? I can figure out the angle here. I can figure that out using trigonometry. Or if I know what the angle is, if I know what the angle is in the right angle triangle, let's say that's 32 degrees, and I know that this is 3, I could figure out what that length is. So these three amigos, I guess, these three functions that allow us to translate between the world of angles and side lengths. Whatever we have, we can find the other. Here are the three. The first one is called sine. The second one is called cosine, and the third one is called tangent. These actually are buttons on your calculator. If you've got a fancy calculator, you might have seen these buttons, but they're not written as sine. It might be written in its abbreviated form, sin, cos, tan. Take a few seconds and maybe look for them on your calculator. Sin, cos, tan. And again, we'll get into the nitty-gritty of these in the next lesson. But all of these are translators between the angle world and the length world. And so sometimes you might have, usually it's written as sine of the angle. And remember, what did we say is like the symbol they use for an unknown angle? Usually it's theta. So sine theta, cos theta, tan theta. And the way you get these things, you can figure out what they are, is you look at the ratios between the lengths on the sides. For sine, the way you get the angle using sine is you take the opposite side, which would be here, O for opposite, and the hypotenuse. So once you know the opposite length and the hypotenuse length, you can figure out the missing angle using this translator called sine. You take the opposite divided by the hypotenuse. Cosine, you can figure out any missing angle by taking the adjacent, we'll call it A for adjacent, and the hypotenuse. So it's the adjacent over the hypotenuse. And in tangent, that's when you can find missing angle using the opposite and the adjacent. Opposite divided by the adjacent length. And some of you may have been taught, there's actually an easy way to remember all these things. I'm not going to mention to you right now. It's a nice little way to remember all these things. In the next lesson, I'll show it to you. Okay, so here's a question, and the only example we're going to do. I want you to tell me what are the sine, cos, and tan values for angle A and for angle B. Okay, so what I want to do is I want to find angle A. So what do I have to divide by to get angle A? So if I want to find the sine of angle A, now since I'm calling it A, I'm not going to put theta here, I'll put the letter A. So the sine of angle A, now the sine up here, it tells me it's opposite over hypotenuse. The opposite over the hypotenuse. So the opposite of A is 3. Okay, so sine A is opposite over hypotenuse. You get the formula written down. And so the opposite of A is 3, and the hypotenuse of A is 5. So it'll be 3 divided by 5, which is 0.6. Okay, we'll work with those numbers later. That is not the angle there. There's another step to that, but that's in the next video. Okay, now let's find the cos of angle A, the cosine of angle A. Well, cosine, as I told you up here, was adjacent over hypotenuse. So what's the adjacent over hypotenuse? What is the adjacent length here? We're looking at A. What's adjacent to A? 4 is. What's the hypotenuse? 5. So it's 4 over 5, which is 0.8. And now let's look at the tangent of A. Tangent is opposite over adjacent. I think it was up here. Opposite over adjacent. And so what's the opposite in this angle from angle A? Opposite is 3, and the adjacent is 4. So it'll be 3 over 4, which is 0.75. So that's for angle A. Now I've got to also do the same thing for angle B. Angle B up here. Are they going to be the same numbers? Not really. Okay, so if I was going to do the sine of angle B, again, it's still opposite over hypotenuse. But for angle B, what's the opposite for angle B? The opposite of angle B is 4. And the hypotenuse is always 5 in this case. So 4 over 5 is going to give you our sine, which is 0.8. The cosine for angle B, cosine again is adjacent over hypotenuse. Adjacent over hypotenuse. So for angle B, adjacent for angle B, adjacent means next to is 3, hypotenuse is 5, so 3 over 5. Which is 0.6, and the tangent of angle B, which is opposite over adjacent, is, there's angle B. What's the opposite of angle B? 4. What is the adjacent? 3. So it's 4 over 3, which is 1.3 repeated. Okay, so all I wanted you to get out of this lesson here is just knowing how to read and find the opposite, adjacent, and hypotenuse, and it's just scratching the surface, just a gentle little introduction to these three amigos here, the translators, sin, cos, tan. The next 2 lessons will go into much more detail on them. So all I want you to do for your skill testing question is find what values you would get for sine A, cos A, and tan A using these numbers there. Okay, hopefully that made sense to you. Thanks, bye.